This is a presentation of MDMA and serotonin syndrome by Lanita Steele
and Enrique Pina.
Our chemical is N-methyl 3,4-methylene dioxyamphetamine, also known as MDMA or ecstasy.
The chemical compound safrole is one compound used to synthesize MDMA. It undergoes two reactions. First, the hydrogen bromide reagent is used to produce an alkyl halide during an addition reaction called hydrohalogenation. Afterward, methylamine reagent is used to produce a nitrogen-oxygen bond during an SN1 reaction mechanism. This is a hydrohalogenation addition reaction between safrole and hydrogen bromide. Hydrogen bromide is a polar molecule composed of bromine, which is highly electronegative. Bromine draws electron density away from the hydrogen, making it partially negative. The hydrogen having the electrons pulled away from it has a partially exposed nucleus, which makes it partially positive. The partially positive hydrogen acts as the electrophile in this reaction, and the negative pi electrons in the alkyne makes this the nucleophile for the reaction. The mechanism begins with the nucleophilic pi electrons reaching for the hydrogen atoms. Hydrogen can only have one bond, so when it is grabbed by the nucleophilic electrons, the electrons that hold hydrogen to the bromide halogen collapses and winds up on the halogen, breaking the molecule. What we get now is a butane now as a butane. Marconi-Karl's rules places the hydrogen on the least substituted carbon for stability. The secondary carbocation gets a positive charge and has now become the electrophile. The bromide ion has started out with 3 lone pairs of electrons, now gets its 4th lone pair to form a complete octet and a formal charge of -1 as the nucleophile. Halogen with his negative extra pair of electrons comes back and attacks the carbocation to give a final product, which is a halogenated alkane or an alkyl halide. This next step is an SN1 reaction mechanism involving methylamine. Currently, the alkyl halide is sitting in a solution as a neutral molecule. And this reaction starts off when bromine grabs the electrons that connected to the carbon chain and breaks away from the carbon atom. Our carbon used to have 4 bonds and now has only 3, leaving it deficient and giving it a formal charge of +1. Bromine now has 8 lone pairs of electrons, giving it a formal charge of -1. Currently, bromine is sitting in a solution surrounded by the partially positive hydrogens of the methylamine molecule. The positive carbon charge and the negative bromine charge cancel out, thus allowing the alkyl halide to maintain a net charge of 0. A methylene molecule will use its lone pairs of electrons to attack the positive carbon, forming a bond between the carbon and the nitrogen. Nitrogen is giving a formal charge of +1, since nitrogen donated its lone pair to the bond, thus forming 4 bonds. Even though nitrogen is the atom holding a positive charge, you will never see another nitrogen come and attack the positive nitrogen because the nitrogen is still an electronegative atom. Instead, what you're going to see is electronegative nitrogen pulling some of the electron density from the nitrogen-hydrogen bond towards itself, making the hydrogen slightly less positive, but at the same time making the hydrogen atoms partially positive. Another methylamine that's in solution will use its lone pairs to grab one of the hydrogen atoms off of the molecules, giving the bonding electrons to the nitrogen atom. The final product will have a nitrogen attached to the carbon chain with 1 lone pair of electrons and a neutral charge. This reaction will produce MDMA.
MDMA was originally manufactured in 1912 by a German company initially intended to help control bleeding amongst patients. It was discovered that MDMA made people feel more social, self-aware, and communicative. MDMA was briefly used in the 1970s by psychiatrists to treat patients with anxiety. However, MDMA was declared a Class I substance by the DEA in 1985 due to the war on drugs. MDMA is currently illegal but has been approved by the FDA to be studied as a drug for PTSD.
With an estimated 2 million pills being smuggled into the US every day, and 1/3 of students at universities like Stanford saying they've tried it, MDMA, or Molly, has become a popular drug of choice. But what exactly is it, and how does it affect your body? Scientifically known as 3,4-methylene dioxy and methamphetamine, MDMA is usually taken in pill form and supposed to be composed of the pure chemical. Ecstasy, on the other hand, is the term for MDMA, which has been chemically altered with other additives like amphetamine or caffeine. In its pure form, MDMA affects the neurotransmitters in your brain. Neurotransmitters are chemicals in your body which relay messages while also controlling things such as reflexes, emotion, and memory. In particular, the neurotransmitter called serotonin controls appetite, sleep, memory, learning, and in this case, mood. When something really great happens in your life, say you fall in love, there's an increase in the release of serotonin from nerve cells, which ultimately stimulates your body and makes you feel happy. And it just so happens that when you take effective amounts of MDMA, these same cells are triggered to release enormous amounts of serotonin, along with other neurotransmitters like dopamine and norepinephrine, which trigger even more electrochemical firing in the brain. This change creates the intense experience of happiness, feeling social, increased empathy, and the inability to sleep, which is likely why it's such a popular party drug. These feelings generally last around 3 to 8 hours as your brain cells naturally work to reuptake the serotonin and have it chemically destroyed. But because MDMA releases so much serotonin, your body also destroys more than usual. This means when your brain function is back in its normal state, there is less serotonin available to bind to your receptors and make you feel good with normal events. This can also lead to a fairly severe hangover with side effects such as negative mood, spouts of depression, irritability, and feeling extra tired. Despite the negative effects, MDMA is being studied as a potential therapy for post-traumatic stress disorder and anxiety. PTSD patients generally have a decrease in brain communication between the amygdala and the hippocampus, but MRI analysis has shown that MDMA actually increases the communication in these regions. However, this treatment remains fairly controversial as studies on rats and monkeys have shown that even small amounts of MDMA can not only destroy the endings of brain cells involved in the release of serotonin, but potentially cause permanent brain damage.
Hi, I'm Dr. Sarah Salimi. Recently, MDMA has shown promise as treatment for patients with PTSD. One study showed that 61% of participants no longer met criteria for PTSD after 2 months of MDMA-assisted psychotherapy. Despite its therapeutic potential, MDMA carries risks of highly toxic side effects, including serotonin syndrome, which can cause seizures, hyperthermia, and in severe cases, death. In 2011, MDMA accounted for approximately 2% of all drug-related emergency visits. MDMA has potential to treat patients with PTSD. However, more research is needed to determine how to use it as therapy in a way that is both safe and effective. Thank you for watching.
We hope you enjoyed.
Bye!
Bye.